Hello, welcome. Today we're going to be looking at calculus. Calculus is a very important mathematics that you have to learn if you're to be writing mathematics in JAMB. When you're in 100 level in the university, you're also supposed to do some things in calculus. Whenever you hear the word calculus, you think about differentiation and integration. What kind of mathematics do we need calculus to solve? Whenever you have expressions or mathematical situations where you have changes, like you have changing velocity, changing acceleration, changing size or container, then you use what we call calculus. And in using calculus, you use the tools in calculus, the limits, differentiation, and integration. So in this our course in calculus, we are going to be covering limits, differentiation, and integration. These three aspects that we are covering under calculus, they are linked together, they are related. From limits, we get to differentiation, and we all know that integration is the opposite of differentiation. So in our time in this course, we'll be looking at these three: limits, differentiation, and integration. So whenever you hear about calculus, we are talking about changes and how to take care of changes mathematically. And this calculus involves limits, differentiation, and integration. So as a matter of getting down the notes, we're going to be looking at calculus, and under calculus we are going to be looking at limits, we are going to be looking at differentiation, and we're going to be looking at integration. Now, mathematically, integration is the opposite of differentiation. When you integrate, you get back to where you were before the differentiation was made to an expression. So we look at this expression. Given this very expression, if you differentiate this expression, you have this. Now, if you integrate this very expression, you have this, which is actually where you're coming from. So when you differentiate an expression, you have a different expression. But when you integrate, you get back to where you started from. You can differentiate using this formula. So in subsequent classes, we are going to be learning how we arrive at getting from here to here, differentiating, and also getting from here to here, integrating. So you're going to be given a simple expression like this in JAMB or in your further mathematics in WAEC, and you're going to ask what is the derivative of this. So when you ask that question, what is the derivative of this expression, it simply means differentiate this, and when you differentiate this, you get this. And this is the simple explanation of this. Anything that you have up here, take it back here, so that you now have x a n. Then anything that is up here, reduce it by 1. So that is what was done here. When you take this over to this side, it becomes 3 times 2, which is 6. Then anything here, reduce it by 1. You have 3 minus 1, which is 2. So that's how you come about this. So with this expression or with this formula, you can always differentiate. So we differentiated this to get this. Then when you integrate this derivative, you get back this expression. So if you integrate this, you get back this. So in subsequent classes, I'm going to be showing us how to integrate, how to differentiate, and the derivatives of some very, very important expressions like cos theta or cos x. How do we differentiate cos x? Cos x equal to sine x as the derivative. Then how do we differentiate sine x? Sine x equal to minus cos x. So all these major derivatives, x and all of them, all these major derivatives, we're going to be looking at them we're going to be getting their derivatives and their integrals as well. So if you're told to find, when you work on this, you get this as the integral. So we have derivative, we have integral. So differentiate to get the derivative, then integrate to get the integral. So that's what we're going to be looking at. And I told us before, calculus has to do with whenever we have changes. Very, very important. It's the kind of mathematics that helps you to solve problem that involves changes. Let's say you have a car. And this car is moving at 30 kilometers per hour. You understand? So what distance will it cover in 3 hours? So you're going to have the distance covered will be 30 times 3. So if this car is actually moving on a freeway, but let's take, for instance, this car is actually moving, but some other things are blocking it. You have other bigger cars or smaller cars that are in front. So this car cannot actually move at a constant speed of 30 kilometers per hour. So provided that it cannot move at this constant speed, sometimes it could move at 20 kilometers per hour. Sometimes it could move at maybe 10 kilometers per hour. It's changing, the speed is changing. So how do you now calculate the distance when it has changing speed? Will the distance still be speed times time? So how do you take care of this change? Because the speed is no longer constant. So you can use derivatives, you can use integrals. So you can actually use calculus to solve this problem. So any mathematical problem that involves changes, you can use calculus to solve. So when we go deeper into how to use these techniques to solve, then you understand how to apply them in problems like this. So we're going to be looking at limits, we're going to be looking at differentiation, we're going to be looking at integration, all in calculus. So one thing to take out of today's course is that whenever you have a mathematical problem that involves changes like acceleration, changing velocity, even in physics and in engineering, you're going to be coming across calculus, you're going to be coming across ordinary differential equations and the rest of them. So we're going to be looking at these in details. Please hit the subscribe button so that anytime we release our videos, you'll be the first to get them. Thank you. God bless you.